Hey everybody, in this next video lesson we're going to talk about how to name ionic compounds that include polyatomic ions in them. And the rules for this are not much different than rules for naming standard binary ionic compounds. First of all, the element in the front, the cation, keeps its name just like it did before. And the second element, the anion, is usually a polyatomic ion. And the polyatomic ions already have special names, and so we don't really even change their names. So it's quite simple, really. You just read what you see. The cation keeps its name. The anion, if it's polyatomic, keeps its name. And then that's it. That's naming with polyatomic ions. Let's take a look at some examples. In this first example, K2SO4, what you're looking at is K, potassium. And remember, the amount of potassiums doesn't matter. So the 2 here just is irrelevant. It's just potassium. And SO4 is sulfate. Now, you might not have a lot of experience with these polyatomic ions, but after you've looked at a bunch of ionic substances, you'll recognize right away that if the anion has more than one atom, it's polyatomic. And if you forget the name of this, just simply turn over your periodic table and look on the back, and you'll find it's going to be one of those 8 common polyatomic ions that we talked about in a previous video lesson. So this is potassium sulfate, and that's it. Name is potassium sulfate. Now this next one, you'll notice there's some parentheses included. Well, that's because this ClO3 polyatomic ion had to be doubled in order to balance the charges with this cation. So ClO3 is a polyatomic ion, so is NH4. So whenever you see parentheses, there's a pretty good chance that what you're looking at is a polyatomic ion. So when you're naming with polyatomic ions, well, that's a dead giveaway. So NH4, this is nitrogen and hydrogen with 4 hydrogens attached to the nitrogen. If you remember from our 8 common polyatomic ions, this is ammonium, and this is chlorate. Ammonium chlorate is the name of this ionic substance. Down here, we've got aluminum, and OH3 means that there's 3 hydroxide ions for every 1 aluminum. The charges have been balanced. So this is aluminum hydroxide. I'm going to pause the video now, quick, and I want you to see if you can come up with the answer to this last one, and then go ahead and play the video and see if you're right. All right, we're looking at CS, which is a cation, cesium, and PO4, which is the anion, phosphate. So this is just simply cesium phosphate. Now when it comes to writing formulas that involve polyatomic ions, treat polyatomic ions no different than you would treat regular monoatomic ions. They have a charge, and the charges need to balance. So showing your work is really important, especially when you're developing this skill. So calcium, remember, is an alkali metal, and it's got 2 valence electrons, so it's going to lose those 2 valence electrons to become 2+ charge. Nitrate, if you remember, or look on the back of your periodic table, and it'll tell you, is NO3 1-. That means the whole thing is a 1- charge, not just the nitrogen, not just the oxygen, the whole thing. So when you're combining these to create formulas, do the same thing you always did. Crisscross, take the 2 and put it down here. But this time make sure you put it outside the parentheses, because we need to double this whole thing. We need 2 nitrates for every calcium. So the formula is CaNO3 parentheses 2. Doubling the nitrate and only 1 calcium. So this is no different if this was like a -1 ion like fluorine. You'd say CaF2. It's just that we don't put the parentheses around F because there's only 1 element, and so we just say it would be CaF2. But since this is a polyatomic ion, we put parentheses around it when we double it. If you don't double it, if it's just singular, you don't put parentheses. But if you put parentheses without doubling it or putting a multiple outside the parentheses, I wouldn't take points off necessarily. Let's take a look at this next one. Lithium is Li, and it's a 1+, as all alkali metals are. And carbonate is CO3 2-. It's one of your 2- ions along with sulfate. So again, treat this no differently. Crisscross. Take the 2 and put it down here, and take the 1, put it down here. When you combine these together, I only need 1 carbonate in this case, so I don't need parentheses. But if, like I said just previously, if you put parentheses around it, I wouldn't take points off, because you're really trying to apply or remind yourself that this polyatomic ion is acting as an individual particle, and I'm cool with that. But typically you wouldn't see this maybe written in a textbook. But the correct formula for lithium carbonate is Li2CO3. Now the next one is strontium phosphate. Now this one's going to be a little bit more difficult, as I tend to when I get further down in my examples. Strontium is a 2+ charge, and phosphate is a PO4 3- charge. Now that whole thing is 3-. So when I crisscross the charges, make sure I put the 2 outside the parentheses when I'm balancing these charges. So what I end up with is SR3PO4 parentheses 2, like that. The 2 goes outside the parentheses because I need 2 times 3 minus to balance out my 3 times 2 plus. Plus 6 on the left, plus 6 on the right. That's why I need 2 of these, because each one of these is 3 minus, so I need 2 of them to balance out the charges of the strontium. Now, once again, I'm going to go ahead and pause this video, and I want you to try this bottom one, which is a bit of a toughie. See if you can do it. All right, this bottom one is a little tough. Furthermore, I have to squeeze it in on the bottom, so let me just scroll up a little bit here. You're going to see a little bit white on the bottom of the screen because I'm going off the slide. But ammonium, you look on the periodic table, you're like, I don't remember that cation. What element is ammonium? I can't find it. Well, you need to really just remember that ammonium is your only positive polyatomic ion. That's really, you just got to remember it. This is why practice, practice, practice. Okay, so ammonium's a 1 plus, and bromine, because it's a halogen, it's bromide. It's not bromate, it's bromide. So an IDE ending means it's just a singular atom. So I look over here and I put a 1 minus charge on. And since it's plus 1 and minus 1, I just simply combine them together, singular. So it's NH4Br, and that's the formula for ammonium bromide. The thing that trips people up the most on this is the fact they forget that ammonium is a 1 plus charge ion. And also, they think everything on the backside is a polyatomic ion. But if it ends in an IDE, you should just simply pick the element from the periodic table. If it's an ATE ending, like nitrate, carbonate, or phosphate, you should pull an element, or polyatomic ion, I should say, off the back of the periodic table. Well, that takes care of this video lesson on naming and writing using polyatomic ions. Thanks for watching.